Talk. So our second speaker for tonight is David Mossop, and David is probably going to provide quite a different topic for you this evening. David is the statewide coordinator for the Environment Protection Authority's Citizen Science program. So David's passionate, like me, about empowering everyday people to be part of the growing citizen science movement. So if you're not familiar with the citizen science term, I'm sure David will run you through it. So citizen science really is about joining scientists with the community. David's got over 10 years experience working in the field of aquatic ecology and has been lucky enough to sample a diverse range of waterways throughout Victoria and beyond. So tonight David's going to talk about how Victorian communities and scientists can work together to identify and better understand waterway impacts. So thank you very much, David.
My preparation for tonight probably actually started a long time ago. This is a shot from a little bit down the road at Apollo Bay, and it was a place owned by some family friends we had. In 1988, I was about 6 years old, and for me, I grew up in Melbourne, so having summer holidays at Apollo Bay really allowed me to explore a different environment, very different from Melbourne. So looking over the back of that photo and down the hill, I'd always jump on the BMX, ride down there, and had a really strong love of fishing. And it was great. I had a ball doing it. For me, it was the fishing and the anticipation and mystery of what was under the water, under that murky water. And, you know, being 6, 7, 8 years old, you don't have a lot of patience as well. So you end up inevitably exploring. And at the time, I was really into nature documentaries, big fan of Malcolm Douglas's work. So those that know his work, obviously he was up in northern Australia. So for him, he'd be doing a lot of fishing, chasing big barramundi, getting amongst the mangroves and chasing mud crabs and that sort of thing. So for me, my mud crabs were little soldier crabs and shore crabs, and everything living down south is much smaller than up north. And instead of my metre-long barramundi, it was more like a undersized bream. But it got me out there, got me in and touching nature and really starting to appreciate it. So today, I'd like to start with talking about some of the values of waterways, and I'd really encourage you all as well to think about your own values and your own connection to the waterways we've got. So not only estuaries, but marine environments and freshwater as well. We'll also have a look at some of the threats to water quality and the natural values of these waterways. And we'll bring things together with a look at citizen science. So onto these values. This is a shot down at Jellybrand River, and yeah, as you know if you've been there, beautiful little spot. But before we get stuck into estuaries, we have to think about, I guess, what's creating those estuaries. And we have to start looking upstream. This is one of the nice little streams as you drive down the Great Ocean Road, and it's well worth a look. I'm sure a lot of you know already, but yeah, taking the time to pull over and get up these creeks is pretty amazing. So we're going to start right at the top. So we're looking at some of these upland waterways, and as you'd know, essentially the water from an estuary starts usually up in the hills, falls down, say around the Otways. That water hits the ground, starts running over it, gets down in little gullies turn into little creeks. These creeks join up, end up as rivers and so on. And when I get up in these sorts of places, it feels great up there. It feels really intact, particularly through the Otways. You've got crystal clear water, you've got really cobbly little streams, and you've got a lot of life there too. And for me, working at the EPA for a few years now, we really use macroinvertebrates quite a lot to understand a bit more about river health. So I'll take you through a little bit about how we actually sample those bugs. Starts off looking something like this. Bit of a sweep net, say you're getting in the creek with waders on, dislodging those bugs off the vegetation and logs. and trying to collect them in the net. From there, we've got a couple of EPA people there, that's Roz and Lisa, and we pop the contents of the nets in a tray, and with tweezers we start picking out the bugs and we preserve them, and then from there we take them back to the lab and have a look under the microscope, and that's where I guess the magic happens. You really get exposed to some of these incredible body forms and adaptations to life in rivers and creeks. And things I guess you haven't seen a lot of before. So, for example, on the bottom right, that's actually an aquatic caterpillar, or two of them. And they're just like your regular caterpillars, except they live underwater. So all those long filaments there are their gills to allow them to breathe. And essentially, when we're going and doing the sampling, we've got a really good idea, some really good models for what we understand to be bugs that need to live in nice areas and nice clear streams that have a low tolerance to pollution. And other end of the scale, we've got those bugs that are really tolerant and can get by in some pretty nasty conditions. This one in particular was a really interesting one from, I guess, the west of the state. This is over at the Hopkins Falls, and so a couple of our really amazing taxonomists, so Ros Sinclair and John Dean, described this new species. It's a type of stonefly that, well, essentially, your everyday stonefly, as far as we know, has a larval stage. So on the far right, you've got that whole animal there. So that'll be in for a matter of months, usually, in living underwater, breathing under there. It gets to a point where it then turns into an adult, emerges from the water. It actually grows wings and then can fly off and continue its adult stage. This particular one is very different though. It reaches its adult stage, but it never actually grows its own wings. So essentially from that larval stage, it still emerges, but then the adults don't have wings, can't fly, and they're just on the wet rocks all around that waterfall there. So have a think about this particular bug, and I'd like to know later on your answers on why you think it never grew wings. And I should point out that John and Ross have a good sense of humour, so the species name there, Walkeri, it was actually named after Ken Walker at the museum, but I'm sure he'd agree having that name helps with a flightless stonefly too. Moving downstream, we hit those middle and lower reaches, those lowland waterways. So typically a little bit slower flow, wider water bodies. Sections like this can resemble wetlands, and a very different sort of system. So you start to get a lot more of the macrophytes or aquatic vegetation, and you get some really interesting critters too. So this is a little Glenelg spiny cray. This is from Darlot Creek over towards Portland. I personally have a really strong interest in crayfish. I think they're pretty amazing, really understudied. And we're lucky enough in Victoria, a lot of people don't know, but it's, as far as on a world scale goes, it's a real hotspot for freshwater crayfish diversity. So we've got over about 40 species in the state. So much more diversity than just the yabby. That's a juvenile, but they do end up like this too. So this is actually just from over the border in South Australia. But yeah, the second biggest spiny crayfish species we've got. Really cool animal. And these things as well, so they live entirely underwater for their lives. So they really rely on good water quality to survive. Very different species, this one. So on the right, you'll see what we call the chimney. You've got it's basically a burrow for this crayfish. You might have seen them around, but it's really rare to see one of these above the ground. So they usually, as stories go, they're usually underground for most of their lives, but over some of the cooler nights over winter when they decide to mate, to actually come above ground overnight and start moving around. But occasionally you will see them above during the day. So these guys are essentially really terrestrial animals, so they don't often, there's a few exceptions, but most of them will live in these burrows, create these huge chambers and different areas underground, and they'll most often get down to the groundwater and be happily living in there. So a different type of water quality, but groundwater for these guys is actually really quite important too. And it's not just things living in the water, obviously. We just saw that crayfish, but then, obviously reptiles and other sorts of animals are really attracted to these waterways. And then we get down to our estuaries. So, as you know, you guys, most of you are actually involved with monitoring some of these estuaries. And we've got a really neat range, I guess, on this part of the coast here. So Wild Dog Creek, we've got little creeks that run over sandbars and get out to the ocean. You got very different substrate here, very rocky. Different sorts of animals can live here. You also got a big range with, there's probably limited range with some of the larger water bodies. So the Barwon, as you would have heard, a lot more flushing with the marine environment. That said, the rocks don't always stay where they're meant to as well. So this was a nice piece of artwork, I guess. And again, this is just down on the ocean road there. And obviously different types of vegetation. So now you're getting your seagrasses and your more saline tolerant species that are, again, really provide that nursery for all types of animals. Amazing bird life down on our estuaries as well. Again, supporting animals that are from far and wide. From up in the northern hemisphere, some birds are coming down to use our estuaries. And obviously the fish, and I won't get too far into that, but we all know about those now. Let's move on to some of the threats to water quality and some of the animals living amongst it. Let's start off with having a look at nutrients and sediments. So these things are obviously naturally occurring through natural processes, but at times we can get a bit too much of it. So nutrients through different types of land use, we can get excess nutrients running off the land into the water. And again, this causes excess algal growth that really smothers some of the other plant life that could be there and can strip the oxygen out of the water, so creating things like fish kills. Sometimes associated with nutrients, particularly if you've got some issues with sewerage, so either through burst pipes or poorly maintained septic systems. We also get bacteria, and that can affect things like recreational uses of estuaries too. As for sediment, again, naturally occurring, the process of soil eventually moving over the land into water. But the point here is we've really changed the way we use the land and how it looks. So on the left there, you've got a highly modified landscape. We don't have the forest that used to be there once upon a time and the grasses that would have retained that soil. So as soon as you get a big rainfall event, that's just going to run straight down the hill, as you can see, down towards the road, and ends up turning creeks and rivers into something resembling a milky coffee. And further downstream, it starts to create sediment slugs and starts to get into some of those spaces that essentially are used by different species, particularly things like crayfish and other invertebrates, as well as fish and other sorts of animals. So once you start clogging up those interstitial spaces, as we call them, you're really limiting the available habitat for different species. The other thing, and this is becoming, I guess, a little bit more of an interest as we go on now, is the relationship between sediment movement and different pollutants. So different pollutants, particular pollutants, can't actually mix very well with water. So they're limited in their ability to hit a waterway and move downstream. But some of these pesticides and other chemicals can actually bind to sediment particles and thereby getting that free transport hundreds of kilometres downstream, potentially down towards the estuaries. So with these pollutants, I guess we have to think about why they got there. How are they in those waterways? So no guessing what this is, but basically I think we need to start looking a lot more at our stormwater system, and it's becoming really a bit of an issue, the fact that these urban centres that we live in, most of us, are really, a lot of it's paved. When that water, the rainwater hits it, it's really washing all these different pollutants down the stream, down the stormwater system, through the gutters, and essentially there's no filter. This goes straight out to the nearest creek or river, so it can be a real issue. And things like hydrocarbons, so oil-based products, can be as simple as a little oil leak at the bottom of your car. These things accumulate over time. Things like pesticides, so your domestic use of weed killers, but all the way through to agricultural use of pesticides as well. And then I guess there's this other big looming issue, is this thing we've got to deal with, is a changing climate. Most recently we had a really a significant event down at Wye River more recently, so not good news for the environment and the community there at all. And the issue with, I guess, fire hitting that environment and around waterways, as you can see, the soil becomes really loose, really mobile as well. So as soon as you get a big rainfall event, you can imagine how easily that's going to wash in to a nearby creek. So, and I'll talk about it in a moment, but we've recently been working with EstuaryWatch and WaterWatch on Wye River in particular. So it brings us to citizen science. And first off, I think it's important to define what we're talking about with citizen science, because there's a lot of different ideas around what it is and what it isn't. In its most basic form, I guess, it is scientists and non-scientists working together on scientific problems. And we think it sits somewhere in this space, so where science, engagement and education converge. And for me, in my experience with EPA and some of the projects we've worked on, I can really see the benefit in combining these things rather than conducting them in isolation. So, for instance, if you create a traditional science program, it's run completely by scientists, you get a science answer and a science report, and then you try to engage with people, it's really hard to bring them along at the end when, if you get them involved early on, I think you can really make some gains there. I think it's a matter of really combining our strengths as well. So obviously scientists and everyday citizens have got, I guess, different backgrounds, different training and different access to equipment, but there's definitely strengths on both sides. And I think by collaborating on projects, you can really get a more complete picture of what's happening in the environment. Quick note on scientific approaches. So for me, I've got a science background, and I'd probably be lying if every project looked as neat as the spiderweb on the right. So everything's transparent. There's a defined way of doing things, and yeah, your data is all there, ready, all filtering into one common spot. But certainly, we're trying to avoid the spiderweb on the left, that approach to science of having some really good ideas, but probably not having that direction, that oversight of data and quality control. You've got, a dark hole where no one knows where data goes there in the middle, and yeah, it's a little bit problematic. So I think if we can work towards the web on the right, I think we're going in the right direction. One option we've got is following the ideas of co-design. So this is a model we've developed where we start off with, from the very get-go, we're involving community members and citizen scientists, getting scientists and community members in the same room and talking, and designing a program to start with that actually incorporates views of everyone. Then we move on to a co-monitoring phase. So people aren't left alone to their own devices. It's scientists actually conducting monitoring as well. And there's a neat I guess you can have a neat tiered approach in this part of the process, in that you can have scientists with potentially more expensive or higher quality equipment, but generally speaking, we've only got so much of that and can only sample in so many areas. So you get a really much more valuable, broader sweep with involving the community as well. And rounding it out with this co-interpretation phase. So essentially, again, like the first phase, you're getting people in the same room talking, incorporating all those different perspectives. So for us, this is a typical meeting at EPA out at McLeod. And for us, we want to really get people involved. So it's not done in-house, it's actually transparent and people are actively getting engaged. We work a bit slower than that though. So essentially, what we're aiming for is to get to a point where we have this shared understanding, where we've both EPA, or as scientists, and the community have worked together on a problem from the start, and we're getting to the same point at the end. So the good news down this part of the state is citizen science is definitely up and running and already happening. It's a little example from a group called the Nature Glenelg Trust, and it follows a lot of work from ARI as well on the Mulloway, and using angler diaries and getting people to send in otoliths to understand a bit more about the species. I'm sure you might have heard about these two, but obviously EstuaryWatch and WaterWatch do amazing work and have done it for a number of years now. So I guess in many ways, particularly WaterWatch, having been around for so long, really provide a good model for citizen science in Victoria and beyond. And our own citizen science program started about 1.5 years ago, and essentially we're looking at, this is an umbrella campaign, so we've got different project components within it, but at the moment we're actually really trying to revamp our pollution reporting for the start. And pollution reporting for me, I guess over the years has been a fairly basic function of EPA, but I really see potential in really revamping that, improving the experience of people and getting them involved, because essentially people like yourselves are the eyes and ears out there. We've only got so many people, we can only be in so many places, but it's really, for me, tapping into the local knowledge, people that are on the ground all the time, and giving them an avenue to come to us with observations they're making out there that can lead to EPA looking further into particular local issues. And for us, we're also looking at different partnerships and smaller campaigns. So currently in conversation with EstuaryWatch and WaterWatch, and trying to establish a statewide partnership. This came particularly on the back of the Wye River event. So obviously a really not a good experience, but from that we really started talking with Rose and Deidre from EstuaryWatch and WaterWatch, and understood that the community did want to get involved, wanted to be able to feel like they're empowered to understand a bit more about Wye River itself, and start to monitor in case there was impacts. And so from the start, even before we really engaged in any scientific design, the background data that EstuaryWatch and WaterWatch had was incredibly valuable. We had very limited data previously, so to give us that baseline that we never would have had before was really valuable to us. The groups down there are continuing doing their monthly monitoring, and it's a really good opportunity, I think, to blend that with that scientist involvement. So here's a few of our guys there out there setting up some logging equipment. So essentially that was put in the water, upstream and downstream of the town, and enabled us to keep logging data continuously in the case of a rainfall event. So that's pretty much where I'll leave it. But in leaving, I would really encourage you again, I guess, to think about how you value your different waterways and your estuaries, and what really inspires you from an early age to get involved and really appreciate the waterways. For me, that was me as a kid. I'm still in it today, and I think I'd really encourage you guys to look at citizen science as an option, to really start getting involved and making a difference. So thank you.